Thank you for joining so early. Honestly, it's my presentation, but it was difficult to get up on the fourth day of the conference. So today we'll talk about this paper, the data minimization principle in machine learning. I want to just give a huge shout out to all my co-authors, Cuong, Reza, and Nando. Without them, this would not have been possible. So let's talk about what is the data minimization principle. Let's go back to GDPR. For folks who might not know, GDPR is the General Data Protection Regulations from EU. And these are the two articles that I care about right now for this presentation. The first one says that personal data shall be collected for a specified, explicit, and legitimate purpose, and not further processed in a manner incompatible with those purposes. In other words, you need to be very explicit about why you are collecting data before you start collecting the data. People call this purpose limitation. And the second half is personal data should be adequate, relevant, and limited to what is necessary in purpose that has been defined. People call this data relevance, and essentially it means you need to be explicit about why you're collecting data, and then you need to collect data only that matters to the purpose that you have defined. You cannot just go around freely collecting data. And this is what together we call the data minimization principle. You need to minimize the data as much as possible. You don't get to collect anything you want. Similar regulations sort of exist all across the world. Like, for example, from Brazil, they have similar language, legitimate, specific, and explicit purpose, and minimum necessary to achieve its purpose. We have South Korea, who also have similar language. There are other regulations from South Africa, from Australia, from the US. If you are interested in that, you should check out the paper. Essentially, the idea is use only the data necessary to achieve the explicitly defined purpose. And when we talk about data minimization in machine learning, the purpose becomes the utility of the model that you're trying to train. Basically, we say that after collecting the data, you need to minimize the data and only use the data that if you train a model on top of it, the utility does not change. You're still getting the same utility, even though you're using less data. There's a bit of math here. I don't personally like math on slides because either you don't like it or you want more of it, but just bear with me. It's minimizing the data while making sure your utility does not drop too much, where the utility itself is defined based on a training of a machine learning model on the minimized data. So it's an optimization inside an optimization. It's a bi-level optimization, which makes it a little difficult to do. So we have a lot of approximations to try and solve it. One thing I want to note before we go forward. So for the whole presentation and the paper, we have this binary data minimization assumption. Either I have your data or I don't have your data. Either I know your age or I don't know your age. But there is a middle ground where I might know a range of your age. And that is more information than not knowing, but less information than exact age. And that is something that has been explored in the literature, but it is not something we talk about here, although I do believe our framework can be extended to that discussion. Okay, so the thing that I really want to talk about is the narrative around data minimization and how it connects with privacy. Going back to these two things, you notice it says personal data shall be collected for specified, explicit, blah, blah, blah. Personal data shall be adequate, etc. If you are curious what personal data is, GDPR does define it. It says personal data is any information relating to an identified or identifiable person. We have a similar definition in Protection Information Personal Act. Information that identifies a particular individual or can be combined with other information to identify a particular individual. In other words, you notice there is a connection to privacy of an individual when we talk about data. When we say data, we are talking about can we identify which individual it belongs to. Despite this implicit expectation of privacy, there is no explicit discussion of privacy when we talk about data minimization. And there is a lot of, despite that, there's a lot of expectation, there's a lot of narrative of, what data minimization can do for us. Data minimization is fundamental to privacy. Data minimization is the way to go when we talk about privacy for data. Even in the EU AI Act, there is a discussion of we really care about data, and the best way to go through that is through data minimization. But the idea is just to set up the adversary, the reason why we care about data minimization is the data that is being collected. There can be data breaches, or there can be other ways in which the data can be accessed, And this is what we care about. We care about an individual who might get access to our data and how they can identify individuals using the data. What we don't care about that much, although is a big part of privacy in machine learning research, is the information leakage after the model has been trained. This is not something that we focus too much on when we talk about data minimization. We don't care about the model being trained. We care about the data itself being breached. So, does data minimization actually protect privacy? Does it have all these expectations that we have been talking about of like being able to protect personal data? It does not. And I'll give a very simple example that is, I feel, very common to privacy folk. Let's say you have this data set about some medical information of a lot of people who were surveyed, and there exists some cancer gene that was found in some people and not found in others. And this data is supposed to be released publicly because it can be used for further analysis and understanding better where it's coming from. There's this really malicious insurance company who thinks, these people who have this cancer gene information, I'll just increase their premium because I have this information about them and I know there's higher risk there, so I can increase their premium. Data minimization says you don't really need the names of people to be able to talk about the overall medical analysis. So you might do something like this. You might say, I'm releasing the rest of the data, but I'm removing the names. And for a second, you might think, I have removed the information. The company just knows there's some female of age 27 from this area who has cancer gene. I don't know who that is. But if they just go back to the public voter database, they can very easily identify who is this female of age 27 of this particular area. We call these linkage attacks. And the idea is essentially data removed is not information removed. There are a lot of features in our machine learning algorithms that are correlated with each other, that are connected with each other. And knowing one feature can give you information about other features, even though they are not visible. And because of that, data minimized does not provide us the privacy guarantees that we want. We have a lot of empirical results in the paper, but I'm going to just go through some key takeaways. One, as we talked about, we formalized the data minimization problem as an optimization problem. We solved the optimization problem using some approximate methods, and we found that you can actually minimize approximately 50 to 60% of the data. So we are collecting a lot of unnecessary data, for sure. However, we see a sort of multiplicity in data minimization. When I say multiplicity, what I mean is that there can be different subsets of the data, all of which give you the same utility, and you're not sure which subset to use. For example, let's say people who have higher income tend to also have higher credit scores. So there can be two different features. You might minimize and say, I'll only collect the credit scores. You might minimize and say, I'll only collect the income. Both of them will give you similar utility, and you're not sure which one to choose. Using actual adversaries and attacking and doing data breach and trying to figure out how much information we can get, we found that minimized data set does not actually equate to privacy. And even if you have minimized a lot of data set, you can still recreate all this information and get back the identification of individuals. But if you explicitly include privacy constraints because of the multiplicity that I mentioned, because of different ways in which you can minimize data set, some of those versions do protect privacy, and you can find them if you are explicit about it. So just to quickly sum up, data minimization can protect privacy, but expecting data minimization on its own to protect privacy will not work. You need to be explicit about the goals, explicit about the fact that I care about certain kind of privacy, and that can help you get better results. Yeah. Thank you.